As we pass beyond the heliosphere and drift through interstellar space, our attention turns outward, toward the stars themselves and the hidden worlds that orbit them. For centuries, humans looked to the night sky and wondered, are there other planets like Earth? Are we alone? At Infinity Beyond, these questions are not just philosophical, they are scientific pursuits. And in recent decades, the answers have begun to emerge. The term exoplanet refers to any planet outside our solar system, orbiting a star other than the Sun. For most of human history, these planets remained invisible, their existence purely speculative. But everything changed in 1992, when the first exoplanets were confirmed, strange, massive worlds orbiting a pulsar. Then in 1990, the first exoplanet around a Sun-like star, 51 Pegasi b, was discovered. It was a gas giant in a tight, scorching orbit, unlike anything in our solar system. Since then, our catalog has exploded. Thanks to missions like Kepler, TESS, Transiting Exoplanet Survey Satellite, and powerful ground-based telescopes, we have now identified over 5,500 confirmed exoplanets, with thousands more candidates waiting to be verified. They range from hot Jupiters that skim the surfaces of their stars to super-Earths, rocky planets larger than Earth but smaller than Neptune. We've found mini-Neptunes, lava worlds, and even rogue planets wandering between stars without any sun to orbit. But the most exciting targets are the planets located in their star's habitable zone, the region where temperatures might allow for liquid water to exist on the surface. These so-called Goldilocks worlds aren't too hot or too cold, but just right, and some of them orbit stars remarkably similar to our own. One such system is TRAPPIST-1, a red dwarf star about 40 light-years away, hosting 7 Earth-sized planets, at least 3 of which lie within the habitable zone. These planets are so tightly packed that if you stood on one, you could see your neighboring planet hanging in the sky, larger than the Moon appears from Earth. Red dwarfs, like TRAPPIST-1, are smaller and cooler than the Sun, and much more common, making up about 75% of the stars in the Milky Way. This suggests that Earth-like planets could be far more abundant than once thought. Detecting an exoplanet is only the first step. The real challenge is determining its atmosphere and composition, and whether it might host life. This is where the James Webb Space Telescope, JWST, comes in. Launched in 2021, JWST has begun to study exoplanet atmospheres by capturing the faint light that filters through them as the planets pass in front of their stars. It can detect gases like water vapor, methane, carbon dioxide, and even signs of biological activity, known as biosignatures. Future missions like LUVOIR and HABEX may one day directly image Earth-like exoplanets, revealing their colors, clouds, and possibly surface features. If we find a world with oxygen, water, and methane coexisting in the atmosphere, it would strongly suggest biological processes, perhaps even life. At Infinity Beyond, we see each new exoplanet as a message in a bottle, a signal that the cosmos is teeming with possibilities. These distant worlds challenge our assumptions, expand our understanding of planetary diversity, and bring us closer to answering the age-old question, are we alone? The truth is, we've only just begun the search. With each passing year, our instruments grow sharper, our methods more refined, and our reach further. Somewhere out there, under the light of a distant sun, may lie another Earth, waiting to be found.